Today, we're diving into something pretty fascinating, the intersection of psychology and technology. We're going to talk about aphantasia and 3D design and explore how something that seems like a limitation might actually be a hidden strength.
So let's just start with the central question, because it really sounds like a paradox, doesn't it? How in the world do you build a detailed, three-dimensional world on a computer if you literally can't picture it in your head first? I mean, it sounds almost impossible.
Well, the condition we're talking about here is called aphantasia. At its core, it's the inability to voluntarily create mental images. People often describe it as having a blind mind's eye. So if you ask someone with aphantasia to picture an apple, they know what an apple is, for sure, but they don't actually see an image of it in their head. Now, your first thought is probably, whoa, that must be a massive barrier to any kind of visual creativity, right? I mean, especially for something as intensely visual as 3D design or modeling. But, and this is a big but, what if that assumption is just completely wrong?
This brings us to a really key idea, the huge difference between seeing something in your mind and just knowing where it is. We're going to unpack what we can call the mind's hidden compass.
So think of it like this. There are two different kinds of mental processing going on. On one side, you've got visual imagery. That's the mind's eye, what we usually think of when we say imagination. But then there's this other thing, spatial imagery. Think of it as a kind of mind's compass. It's this intuitive, non-visual gut feeling for where things are in relation to each other.
So what exactly is this spatial imagery? It's not about pictures. It's all about relationships. It's your brain's grasp of physical space, of how objects connect to each other. It's that built-in sense of dimension and scale, of layout and structure. Think about how you can walk through your bedroom in the pitch dark. You aren't seeing the furniture, but you know where it is. Yep, that's your mind's compass at work.
And here is the absolute game changer. Research shows that even if the mind's eye is blind, the mind's compass, this incredibly powerful spatial imagery, it remains strong. In fact, it's often exceptionally sharp in people with aphantasia.
So how does this mind's compass actually translate into, making stuff? Well, it all comes down to understanding the difference between your what and your where, and how we turn ideas into actual structures.
First, let's talk about the what. This is just the conceptual knowledge. You know what a car is. It has four wheels, doors, a steering wheel. It's basically the collection of facts and properties about an object, the data.
And then you've got the where. This is all about spatial processing. It has nothing to do with the visual look of the car, but everything to do with its dimensions, the position of the wheels relative to the body, how the doors are hinged. It's the blueprint of how it exists in space. So for somebody with aphantasia, the challenge isn't a lack of understanding of the where, not at all. Their spatial sense, that internal blueprint, can be perfectly fine, even fantastic. The difficulty is just in generating a voluntary mental picture of the what. They know the data, they just don't see the image.
So if you have a really strong where, but you can't see the what, how do you create something visual? This is where technology steps in. Let's take a look at how AI is bridging this exact gap.
Get this, a lot of the modern AI-powered 3D design tools are completely changing the game. They don't operate on, show me a picture from your head. Instead, they operate on instructions, on data. They are literally built to work with a mind's compass, not a mind's eye. So the creative process starts to look a little something like this. You start with the concept, the what. Let's say a cool sci-fi spaceship. Then you use your strong spatial processing, your where, to define its rules. The engines go here, the cockpit is this big, the wings are at this specific angle. You just input these spatial instructions into an AI tool, which then does the work of translating that data into a visual, tangible 3D model.
So what's happening here is that these tools effectively become an external mind's eye. They take the creator's powerful, non-visual understanding of space and structure, and they do that final step of rendering it visually. The creator provides the where, and the AI manifests the what. It's a perfect partnership.
And this all leads to a really powerful conclusion. This isn't just about finding a clever workaround. No, this is about achieving a totally different kind of expertise, what we're calling spatial mastery. It's about empowering every single kind of mind.
And let's be really clear on this. This is not a story about fixing a deficit. Aphantasia isn't something that needs to be corrected. This is about providing the right tool for a completely different kind of cognitive strength, a different path to mastery.
This points to a much bigger, much more exciting future for technology and creativity.
The goal isn't just to make everyone think and create in the exact same way. The true potential is unlocked when technology can complement our diverse cognitive styles, unlocking abilities we never even thought possible.
So the key takeaway here, the big idea, is this term, spatial mastery. The ability to absolutely excel in a visual field, not in spite of having a non-visual mind, but because of its unique strengths in understanding space, structure, and systems.
And that leaves us with a final, really important question. What kind of future is possible when our tools are smart enough not just to accommodate our differences, but to actively empower the unique strengths of every kind of mind? It's pretty exciting to think about. Thanks for tuning in.